Dear students, welcome to my classroom. Today, I am going to introduce the most important and most interesting section in the branches of mathematics, and that is trigonometry. The word trigonometry is derived from the Greek words tri, gon, and metron. Tri means that three, gon means that sides, and metron means that measure. In fact, trigonometry is a branch of mathematics that studies relationship between side lengths and angles of a triangle. In ancient times, trigonometry was used to find out the distances of the stars and planets from the earth. Even today, most of the technologically advanced methods used in engineering and physical sciences are based on trigonometrical concepts. Even in many aspects of our daily life, we unknowingly use trigonometry. In this chapter, we will study some ratios of the sides of a right angle triangle with respect to acute angles called trigonometric ratios of the triangle. We will restrict our discussion to acute angles only. However, these ratios can be extended to other angles also. We will also define the trigonometric ratios for angles of measure 0 degrees and 90 degrees. Let us see how to name the sides of a right angle triangle. Consider a triangle ABC in which B is a right angle. And we can see that AC is the longest side. So the name of the AC is hypotenuse. With respect to angle A, we know that BC is opposite to A. So the side BC can be named as opposite side of angle A. And also AB is adjacent side of angle A, because here the side AB is adjacent to angle A. So we can name AB as adjacent side of angle A. And with respect to angle C, we can easily say that AB is the opposite side of angle C, and BC is the adjacent side of angle C. Okay. This is the process of naming the sides of a right triangle. Now, let us do an activity to find the trigonometric ratios. Draw a horizontal line on paper. Let A be the initial point and mark other points B, C, D, E at a distance of 3 centimeters, 6 centimeters, 9 centimeters, and 12 centimeters respectively from A. Now, draw the perpendiculars BP, CQ, DR, and ES of lengths 4 centimeters, 8 centimeters, 12 centimeters, and 16 centimeters from B, C, D, and E respectively. Then join AP, PQ, QR, and RS like this. By finding the distances AP, AQ, AR, AS, we get AP as 5 centimeters, AQ as 10 centimeters, AR as 15 centimeters, and AS as 20 centimeters. From this picture, here we have 4 right angle triangles. They are ABP, ACQ, ADR, and AES. We can say that all these 4 triangles are similar because in every 2 triangles that we take, the angle A and the right angle are common. So by angle property, we can say that all these triangles are similar. Okay. Now, take the table like this. Name of the triangle, length of hypotenuse, length of opposite side to angle A, length of adjacent side to angle A, opposite side by hypotenuse, adjacent side by hypotenuse. Now first take the triangle ABP. In this triangle, we have seen that the length of hypotenuse is 5 centimeters. And the length of opposite side to angle A is 4 centimeters. And the length of adjacent side to angle A is 3 centimeters. Now the ratio opposite side to hypotenuse is 4:5. We can write it as 4/5. And the ratio of adjacent side to hypotenuse is 3/5. Now take another triangle ACQ. Triangle ACQ. In this triangle, we have hypotenuse 10 centimeters and opposite side to angle A is 8 centimeters and length of adjacent side to angle A is 6 centimeters. Now the ratio between opposite side to hypotenuse is 8/10. Opposite side is 8 and the hypotenuse is 10. So we have 8/10 and we can simplify it as 4/5. 2 4s are 2 5s are. And the ratio between adjacent side to hypotenuse is also 6/10, which is equal to 3/5. And now take the third triangle ADR. In this triangle, hypotenuse is 15, length of opposite side to angle A is 12, length of adjacent side to angle A is 9, and the ratio between opposite side to hypotenuse is 12/15, which is equal to 4/5 again. And the ratio between adjacent side to hypotenuse is 9/15, which is equal to 3/5 again. And by taking fourth triangle also, that is triangle AES, the length of hypotenuse is 20, length of opposite to angle A is 16, and adjacent to angle A is 12, and the ratio between opposite to hypotenuse is 16/20, which is equal to 4/5, and last adjacent side to hypotenuse is 12/20 is equal to 3/5. The students, by observing this table, we can conclude that in all these similar triangles, the ratio between opposite side to hypotenuse is same, isn't it? All these blocks have 4/5. Okay. So we can conclude that the ratio of opposite side of an angle and length of the hypotenuse is constant in all similar right angle triangles. This ratio will be named as sine of that angle. What? Sine. Sine of that angle. Similarly, in the last column also, all boxes have the same ratio, 3/5, 3/5, 3/5, and 3/5. So we can also conclude that the ratio of the adjacent side of an angle and length of hypotenuse is constant in all similar right angles. And this ratio will be named as cosine of the angle. Okay. Similarly, the ratio of opposite side and adjacent side of an angle is constant and it can be named as tangent of that angle. Okay, students. Now, let us see how to write ratios in a right angle triangle. Take a right angle triangle in which right angle B and AC is the hypotenuse. So in this right angle triangle, with respect to angle A, the opposite side is BC and AB is the adjacent side. Okay, and his AC is the hypotenuse. Now, sine of angle A, which you have seen in the previous activity, sine of angle A is denoted by sin A, sin of angle A. Sin A is equal to length of the side opposite to angle A by length of hypotenuse, which is equal to opposite is BC and the hypotenuse is AC. BC by AC. So the trigonometric ratio sin A is equal to length of the side opposite to angle A by length of hypotenuse, and in this triangle this sin A is equal to BC by AC. And cosine of angle A, cosine of angle A, and according to the previous activity, cosine of an angle is the ratio between the length of adjacent side and length of hypotenuse. So cosine of angle A is denoted by cos A. Simply we can write it as cos A, C-O-S-A, cos A. And this cos A is the ratio between the length of the side adjacent to angle A to length of hypotenuse. And from this picture, the cos A is equal to adjacent side AB and the hypotenuse is AC. And tangent of angle A. Tangent of angle A is denoted by tan A. T-A-N, tan A. Tan A is equal to, the ratio tan A is equal to length of the opposite side to angle A by length of the adjacent side to angle A. And from this picture, tan A is equal to opposite by adjacent, that is BC by AB. These three are the basic trigonometric ratios, and the multiplicative inverse of sin A, multiplicative inverse of the ratio sin A is denoted by cosecant of A, cosecant of angle A, and simply we write it as cosec A. Cosec A is multiplicative inverse of sin A. So that cosec A is multiplicative inverse of sin A is here, length of hypotenuse by length of the side opposite to angle A, and which is equal to AC by BC here. And similarly, the multiplicative inverse of cosine of angle A, that is cos A, multiplicative inverse of cos A is denoted by secant of angle A, and it can be written as sec A. Sec A is the multiplicative inverse of cos A, so that sec A is equal to, here the inverse of cos A is length of hypotenuse by length of the side adjacent to angle A, so that AC by AB. And similarly, the multiplicative inverse of tangent A is denoted by cotangent of A, and it is denoted by cot A. Cot A is equal to multiplicative of tan A, that is length of the side adjacent to angle A by length of the side opposite to angle A, that is AB by BC. So these trigonometric ratios were very important to solve the chapter trigonometry. So simply we can say that sin A is equal to opposite by hypotenuse, cos A is equal to adjacent by hypotenuse, tan A is equal to opposite by adjacent, cosec A is equal to hypotenuse by opposite, sec A is equal to hypotenuse by adjacent, and cot A is equal to adjacent by opposite. Okay, students. Now, let us do some problems under the title, Do This. The first one is, find sin C, cos C, and tan C in the adjacent triangle. Here the triangle is like this. And let's see the solution. So students, here we have the triangle ABC in which the hypotenuse is 13 centimeters and the side BC is 5 centimeters. So here we have to find sin C, cos C, and tan C. So to find all these trigonometric ratios, we need all the sides. But here we have only two sides. So by Pythagoras theorem, we can write square of the hypotenuse is equal to sum of the squares of remaining two sides. That is AC square is equal to AB square plus BC square. So substituting the values from this picture, we get 13 square is equal to AB square plus 5 square. Here we don't know the value of AB. And by simplifying this equation, we get AB square is equal to 144 and AB is equal to root 144, which is equal to 12 centimeters. Now we have all the three sides of this triangle. Now the first one we have to find is sin C. So sin C is equal to, we know that sine of angle C is equal to opposite side to angle C by hypotenuse. So opposite side to angle C by hypotenuse and is equal to, here the opposite side to angle C is AB and hypotenuse is AC, AB by AC. So the values of AB and AC are 12 and 13. Therefore, sin C is equal to 12 by 13. And similarly, cos C. Cos C is equal to adjacent side to angle C by hypotenuse. That is BC by AC. So here we have BC is equal to 5 and AC as 13. So 5 by 13. And similarly, tan C is equal to opposite side to angle C by adjacent side to angle C. So that is AB by BC and is equal to 12 by 5. So that's all, students. So like this, we can solve this type of problems. And let us see another problem. In a triangle XYZ, angle Y is right angle. XZ equal to 17 meters and YZ is equal to 15 centimeters. Then find sin X, cos Z, tan X. Sorry, students, here we have only meters. This is not centimeters. Take it as meters. So this is the picture. Let us see the solution. In this picture also, we have only two sides of this right angle triangle. So to find other side, we have to use Pythagoras theorem. So this from this figure, we can write xz square, that is square of the hypotenuse, is equal to sum of the squares of remaining two sides, that is xy square plus yz square. So substituting values and simplifying, we get xy is equal to 8 meters. Okay. Now we have all the sides of the triangle XYZ. Now take first one, sin X. Sin X is equal to opposite to angle X by hypotenuse. That is YZ by XZ and is equal to 15 by 17. And second one, cos Z. Cos Z Here we have to observe the angle also. Okay, cos z. Cos z is equal to adjacent side to angle z, not to angle x. Okay, adjacent side to angle z by hypotenuse. That is again yz by xz. 15 by 17. Students, observe here that both sin x and cos z are equal. And third one is tan x, and tan x is opposite by adjacent, that is yz by xy is equal to 15 by 8. Okay. Take another another problem. In a triangle PQR with right angle at Q, the value of angle P is x. PQ is 7 centimeters and QR is equal to 24 centimeters. Then find sin x and cos x. We solve this problem also like previous problems. So for just I am presenting the solution here. I am not explaining. You can understand it. Okay. Students, please watch carefully. Okay. Sin x is equal to 24 by 25 and cos x is equal to 7 by 25. So now let us solve the problems under the title, try this. In a right angle triangle ABC, right angle is at C. BC plus CA is equal to 23 centimeters and BC minus CA is equal to 7 centimeters. Then find sin A and tan B. Students, here the values are given as the sum and difference. So draw the triangle ABC. Here we don't know the sides of this triangle, but here it is given that the sum of BC and CA is 23 centimeters and the difference of BC and CA is 7 centimeters. And angle C is 90 degrees. Now, these are two linear equations. So by solving these two equations, we get BC equal to 15 centimeters and CA is equal to 8 centimeters. Okay. So you can check the answers. Now, we have BC is 15 and AC is 8. Now, by Pythagoras theorem, we can write AB square is equal to AC square plus BC square. And after simplification, we get AB is equal to 17 centimeters. Now, again, sin A is equal to opposite side to angle A by hypotenuse. That is equal to BC by AB, which is equal to 15 by 17. And similarly, we can also find tan B, like 8 by 15. Okay. Students, now let's solve the problems under the title Think and Discuss. Does sin x is equal to 4 by 3 exist for some value of angle x? Observe the question carefully. Does sin x is equal to 4 by 3 exist for some value of angle x? Do you think so? Let us see. We know sin x is equal to opposite side to angle x by hypotenuse, isn't it? Students, we know that in a right angle triangle, hypotenuse is the longest side and the remaining two sides are smaller than hypotenuse. Either opposite side or adjacent side, both are less than hypotenuse. So in this fraction, we have a small value in numerator and big value in denominator because hypotenuse is greater than opposite side. So this is a proper fraction. Okay. But here it is given that sin x is equal to 4 by 3, which is improper fraction. In any type of triangle, sin x is proper fraction. But in the question, it is given that sin x is 4 by 3, which is improper. So sin x is equal to 4 by 3 does not exist in any triangle. Okay. Now let us see the second one. The value of sin A and cos A is always less than 1. Why? This is the question. Students, we know sin A equal to opposite side to angle A by hypotenuse. As per the previous problem also, we have seen that sin A is a proper fraction because opposite side is smaller than hypotenuse. And similarly, cos A is also a proper fraction because adjacent side is also smaller than hypotenuse. So here we have sin A and cos A as proper fractions. But the value of proper fraction is lies between 0 and 1, isn't it? The proper fraction is lies between 0 and 1. So that sin A and cos A is always less than 1. Okay. So let us see next one. Tan A is product of tan and A. Is it right? Is tan A is product of tan and A? No. Tan A is not the product of tan and A. Tan A is the ratio between the opposite side and adjacent side angles with respect to angle A. Okay. Next one, is sin A by cos A equal to tan A? Let us check whether sin A by cos A equal to tan A or not. Take sin A by cos A. So, as per the trigonometric ratio formula, we can write sin A as opposite by hypotenuse and cos A as adjacent by hypotenuse. Now, cancelling hypotenuse, we can write it as opposite side to angle A by adjacent side to angle A, which is equal to tan A. So, the sin A by cos A is always equal to tan A. So, students, remember this equality. Sin A by cos A is equal to tan A. We use this equality as formula in many problems. So, don't forget this equality. Sin A by cos A is equal to tan A. Next one, is cos A by sin A equal to cot A? Let us check it also. Cos A by sin A is again equal to adjacent side by opposite side, which is equal to cot A. So, it is also the formula to remember that cos A by sin A equal to cot A. Okay, students. So, that's all for today. And in next class, we are going to solve an exercise. So, don't miss the next class. See you in next class. Bye.